Okay, so today we're going to be talking about the laws of exponents, and there are a lot of laws of exponents or rules, but I have a step-by-step procedure that will help you with any of these laws in a little bit simpler way than having all these rules memorized. These rules are good to be familiar with, but really the only ones that you need to have memorized are the zero exponent. So this just tells me that if I have an exponent of 0, no matter what the base is, your answer is 1. So if it's a letter to the power of 0, the answer is 1. If it's a gigantic, huge number to the power of 0, the answer is 1. So we have 18 million to the power of 0, that just gives me 1. Or if I have -10 to the power of 0, the answer is just 1, always. So my rule for exponents of 0, it's just always equal to 1. So if you see an exponent of 0, what you need to do is just draw an arrow through it and write a 1, because you can replace it with the number 1. Another one that we need to have memorized is just the power of 1. So kind of like when we first learned fractions, and we know that a whole number has an invisible denominator of 1, we know that a whole number has an invisible exponent of 1. So pretend I have the number 2. That's the same thing as writing 2 to the power of 1. If there's no exponent there, then you know the exponent is 1. The next two rules are the product rule and the quotient rule. If you follow my steps that I'll show next, you don't have to have these memorized. This is just telling me that if I'm multiplying like bases, I add exponents. If I'm dividing like bases, I subtract. But we don't have to worry about those because my rules for the next part will help. The next two we do need to memorize. So, a power, when raised to a power, you do multiplication. So, if I have 7 squared cubed, that just means I need to multiply the powers by one another to get my new exponent. If I have a negative exponent, I need to flip the fraction. This is probably the trickiest one because when we see a negative number, we want to think that it's just a negative number, but it's not. It means to take the inverse. So if I have 10 to the -2, it's just the same thing as flipping this fraction and making this 2 positive. So it ends up being 1 over 10 squared. It just means we are taking the inverse, which just means we are flipping this number to be on the bottom. The next two, we kind of have to have memorized. It's just a little bit like the distributive property. So our rules that we're going to look at next cover this. But I just want us to realize that if there is an exponent on the outside of parentheses, it needs to go to every part of what's inside the parentheses. So this exponent needs to be distributed to the m and to the 5. And we get m to the power of 4 over 5 to the power of 4. This one, it needs to be distributed to both the 2 and the t, because you want it to be distributed to both of the factors. So this probably feels overwhelming right now, but hopefully when we do a couple of simplifying expressions, we can start to get a hang of it. So the rules that I came up with for simplifying exponential expressions includes all of those specific rules that we just looked at. It just includes them in a way of application rather than just rules that you try and memorize. So let's look at an example to try and start understanding this. When given an exponential expression, the first step I'm going to do is rewrite that expression with multiplication signs between every factor and exponents of 1 when there is no exponent. So what I'm going to do is think about, okay, I've got a lot of different factors. So what I need to do is rewrite this with a multiplication sign between all of the factors. Once I have done that, I also want to add exponents of 1 where there are no exponents. So I'm going to put a 1 right here and a 1 right here. That just helps me remember that there is this invisible exponent of 1 on every factor. So now notice that everything separated by a multiplication sign has its own exponent. The next step I'm going to do is distribute power of powers. This is one of our rules that we said we need to memorize. In order to distribute power of powers, that just means that I've got an exponent on the outside of some parentheses. So I need to make sure I multiply this exponent by all of the exponents inside the parentheses. So I'm going to carry down what's on the outside of parentheses. And then my inside of parentheses ends up being 4 to the power of 1 times 2, which is just 4 squared. I need to multiply 2 by -4. So I get -8. And then I need to also multiply 2 by -2. So what I've done is gotten rid of my parentheses by distributing this 2 to each of the factors. So each part that's separated from by a multiplication sign. My next step is to add a denominator of 1 if the expression isn't already written as a fraction. So what I'm going to do is rewrite this long expression as a fraction. So that just means I'm adding a denominator of 1 because that's technically not changing the mathematical expression. The next step tells me, okay, now we care about negative exponents. So what I need to do is circle each factor that has a negative exponent. I need to rewrite this expression with the negative exponents moved to the opposite side, because this makes the exponent positive. So when I rewrite this expression, I'm going to keep the numbers I don't have circled at the top, and I'm going to move the numbers I do have circled, I had my 1 already on the bottom, to the bottom, and their exponents are now positive. The next part makes what I'm doing a little bit easier because it's a little more visual than just memorizing these steps. So I know that an exponent is just repeated multiplication. So what I can do is write this in expanded form. So I have the number 6. And I know that y to the power of 5 just means that I'm multiplying y by itself 5 times. So it's just written as y times y times y times y times y. I also have this 4 squared. I know that 4 squared is 4 times 4. Then I'm going to move on to the bottom. On the bottom, we have a 1. We have an x. We have 8 more x's. And we have 4 y's. Once I have it fully expanded, then I can start canceling out things that are the same on the top as the bottom. So I have 1, 2, 3, 4 y's on the top, and I have at least 4 y's, on the bottom, and I have at least 4 y's on the top. So those just cancel out. They go away. Now I'm going to look to see if there's anything else the same on the top as there is on the bottom. I don't see any other similarities. So what I'm going to do is multiply the coefficients. So I get 6 times 4 times 4. Then I don't want to forget my y, over 1 times x times x times x times x times x. We have 9 x's total. Two, 3, 4, 5, 6, 7, 8, 9. And then I can just simplify it. So I know 6 times 4 is 24. Times 4 is 96. And then we need to put our y all over. Multiplying by 1 doesn't change anything. So we're just going to count up our total x's, and we get x to the power of 9. And that is that original expression in its simplest form.